This is CPM Precalculus Chapter 1, number 57. So we're looking at lines and equations of lines, and here we're starting by applying the process to find the equation of the line through point 1, 2 and point 7, 5. Using the diagram below, answer the following questions in your team study. Okay, in your study team. What are the coordinates of point A? Okay. So what are the coordinates of point A? Okay, and we're looking at these two diagrams. Here we have point A, right? Point A here in red. We know point A. What do we know about it? It's right under our 7, 5 point, right? So vertically has the same, x value, yes? And the height is the same as, so it's right horizontally in alignment with point 1, 2. So quickly, well, not quickly, but to get to point 1, 2, we go to the right 1, right, and up 2. So this is going to be 1, this is like 1 and 2, right? So you know that's how we got point 1, 2 here. And to get point 7, 5 here, we know we go to the right 7, so 1, 2, 3, 4, 5, 6, 7, right? 7 here and then up 1, 2, 3, 4, 5. So this right here in alignment with this point is 5. So point A, now we can see, is just to the right along the x-axis to 7 units and then up 2 units, right? So point A is just going to be 7 to the right, comma 2 up. So we have point 7, 2. And now we're asked in part B to find the slope of the line between points 1, 2 and 7, 5. So 1, 2 and 7, 5. So what's the slope? Well, we know the equation for the slope is just our rise over the run, right? Which is, our rise is our change in our y values, and our run is the change in our x values. And that's the same thing as picking 2 points, subtracting the y values, right? So it's y2 minus y1 divided by, subtract the x values, x2 minus x1, okay? And we have 2 points right here, right? We have 1, 2 and 7, 5. Here's where like this translation gets a little bit less confusing because we have a 2 subscript and a 1 subscript, a 2 subscript and a 1 subscript. Okay, well, which point corresponds to number 1 and which one corresponds to number 2? Well, it doesn't matter as long as you pick one as point number 1 and pick the other as point number 2 and then keep that consistent. But the one you pick doesn't matter, you'll get the same answer no matter what. So let's just say this is number 1 and this is number 2. Okay, if you chose this to be number 1 and this to be number 2, you'll get the same answer. But if this is 1, that means this is x1, y1. And this is x2, y2 over here. So plugging those values in, or we're just substituting in y2. Well, y2 is over here in point number 2. The y value is 2 minus y1 over here in point number 1 is y1 is 5 divided by x2. Well, it's from point number 2 over here, 1 minus x1 is from point number 1 to x value 7. Okay, so that's all we do is pick one point to be number 1, the other to be number 2, and then plug in and substitute the values. So then we can just say 2 minus 5 is negative 3, 1 minus 7 is negative 6. Okay, 2 negatives, when you divide one negative by a negative, that becomes positive, right? So I can even write positive. 3 divided by 6, we know if we could reduce this and simplify it, and that we could divide the top by 3 and the bottom by 3. So that's one way of thinking about what we're doing when we simplify, which is just 1 over 2. So 3 over 6 we know is 1 over 2. If we plug that into our calculator, we would get 0.5, and that's the same as over here. So 1/2 or 0.5 for part B. Okay, so let me box my answer. Let me go up and make sure I box it for part A, and go on to C. C says, what are the coordinates for point B? Okay, so point B, let's go look at it in a different color. So point B is right here, right? And we know point B goes, along the x value, it's x comma y, we know goes to the right by, where does it stop? If you kind of eyeball it, it's around 1, 2, 3, 4, 5, 6, 7, 8, 9-ish, right? We know it's around 8, 9, 10, around there for x value. And going up, we know it's exactly 2. So we know point B has something, we're not quite sure, but we know it goes up to exactly, right? And we're actually told, right, here's x comma y. We don't know exactly the x value. We can eyeball it, right, and guess or approximate, but exactly we don't know. So let me put a question mark there. So for part C, now I'm going to go ahead and answer it, is what are the coordinates of point B? Well, we know it has some x value, which we don't know, and some y value, which we do know. So I'm going to just call that x comma 2, leaving x as some unknown variable, right? Because we're not sure. We're not sure what x is. So this is very valid, and this is the answer for part C. Is we have some x value, and we know the y value for sure is at 2. Okay, that's part C. Part D. Using the same process you used to find the slope between 1, 2 and 0.7, 5, find an expression for the slope of the line, but this time use the points 1, 2 and x, y. Okay, so let's see, part D I'm going to do over here. Now we're given points 1, 2 and x, y, right? So again, this is the same process that we looked at before when we're looking for the slope. It's just rise over run, or delta y over delta x, the change in y over change in x, or y2 minus y1 divided by x2 minus x1, right? So we have 2 points, and this time one is x and y. That might look a little confusing, but let's just pretend for now that those are numbers and they're not confusing. So because we're just going to be plugging them in, it doesn't really matter what they are. So how do we start this? Remember, we pick a point to be point number 1 and pick one to be point 2. It doesn't matter. Once we pick, we know this is x1, y1 because it's point number 1. And this is x2, y2 because it's from point number 2. Okay? Now we can plug those values in. We know y2. What's y2? Well, it's just y. y1 is 2. x2, point here is number 2, so we have x minus x1 is 1, right? We're just substituting in, and this is actually the expression for the slope, right? Slope equals our slope for part D. So this is exactly how we express the slope when we're given one of the points as just variables. Okay, we're plugging those variables in here and here. Okay, so we're done with part D. So let's move on to part E. Since the slope between any 2 points on a line is constant, okay, we know on a line the slope is always the same, so it's constant. The slope you calculated in part B, which is, let me use another color. The slope we calculate in part B, right here, our slope is 0.5, okay? and the expression you wrote in part D, here's our expression, are equivalent. So they're saying because these 3 points are on the same line, right? Here's a point, and here's a point. All these 3 points are on the same line. That means no matter how you calculate the slope, they're going to be the same, right? The slope is constant on the line, so the slope, m, is the same no matter what 2 points you use to calculate it. Okay, so that's what that's saying. Set them equal to each other. Okay, so let me move to the right a little bit. So part E is saying to set these two parts equal to each other. We have on the left 1/2 or 0.5, and on the right we have y minus 2 divided by x minus 1. Okay, so I set them equal to each other, and then it says, this gives you an equation for the line through any arbitrary point, x comma y, that is on the line. Okay. Multiply both sides by x minus 1. This final expression is referred to as the point-slope form of a line. Read over the math notes box on this topic before proceeding to the next problem. Okay, so let's kind of consume what we just read and break it down. So what this says is, this is an equation for the line through any arbitrary point xy. So no matter what xy point we choose on our line, remember it has to be on this same line. So any point x comma y on this line has this equation. Okay? Okay, sounds good. Kind of, right? So, but it's true. So just bear with me. This is a little confusing, but that's what it's saying. Okay, so let's multiply both sides by x minus 1. So here's our equation, and I'm going to multiply both sides by x minus 1, right? Let me erase e and move it to the left, because we want to multiply by x minus 1 on both sides. Okay, so this is part E. Let me erase this. So when we multiply our equation by x minus 1s on both sides, you see here on the right, x minus 1 cancels with x minus 1 over here, right? Because this is over 1 and this is over 1, right? So what we're left with is 1 times x minus 1 is just x minus 1 over 1 times 2 is 2 equals y minus 2 over 1. Over 1 we can leave out. Okay. So now this is telling us that this is the final expression. It's called the point-slope form of the line. Okay? Read over the math note box. Okay, so are we happy with this? Let's think about it. Yes, I guess, yeah, I'm okay with that. So that is the final expression, and that's called the point-slope form of a line. Okay? So now let's look at the math notes. So that's on the next page over there. The math note says point-slope form of a line. A line with slope m, okay, if we're given a slope m, and it passes through point x1 comma 1, so we have a slope and a point, okay, x1 comma y1, can be written in the form, so when we have a point and a slope, it can be written in the form as y minus y1 equals to m times x minus x1. Okay, that looks familiar. That's the point-slope form that I'm used to right there. Okay, or it says y is equal to m times x minus x1 plus y1. Well, that So they're giving us two forms in the math notes. If we start with this equation, which we're used to, and add y1 to both sides, then we are left with just y on the left, and we have m times x minus x1 plus y1. Okay, so this is another way of writing it. That's all they're saying. And then they give you an example where you're given the slope and a point, and you can plug it in, and you get the point-slope form of the line. Okay, sounds good. So that finishes part E. I went through the math notes, and now we're going to part F. Okay, part F says, now let's look at any arbitrary line like the one shown in the diagram. What are the coordinates of point C? Okay, so now let's go back here. I'm going to clear everything else away because now we're focusing on this diagram for part F. Okay, it says, what are the coordinates of point C, right? So point C, if this point is x1, y1, right, that means it went to the right x1 point and up, right, this part right here is y1. Up here we see it goes to the right x, so if this is point x comma y, and up y, right? So C is going to have the point, well, it goes to the right x and up y1. Everyone see that? Because here is the y value and here is the x value. We captured them from this point and this point. Okay, so the coordinates of point C are x comma y1. Okay, that is part F. G. Oops. G. What am I doing here? Part G says, find the expression for the sides of the slope triangle. Okay, so G, our slope triangle. Okay, so here we have a triangle, right? So I'm going to draw it again. And we have point C here. I'm just drawing this. We have point x1, y1, right? And we have x comma y. And we know C is x comma y1. So they're asking us, what are the expressions for the sides of the slope triangle? Well, we know this is the line, right? It's going across like that. And so our sides of the triangle are right here and right here. Okay, so these are just the sides in the diagram right here and right here. Okay? So one of our sides, if we look at here, this side right here, right, is the same as this one. What's the length of that side? Well, it starts right here at y1 and goes up to y. So that's equal to, well, the height here is y, and the height here is y1. So that's equal to y minus y1, right? And the height here, or not the height, the length here, it starts at x1 and goes to x. So that's just equal to x minus x1, right? Another way you can look at it is just looking at the distance formula. You know, distance formula is x2 minus x1 squared plus y2 minus y1 squared, right? And then we have 2 points. So the distance here, we call this d1. d1 is equal to, let's choose this point number 1, point number 2. It's going to be 0.2x, so it's x minus x in point 1, x squared plus y2 in point, so 0.2, y is y1, minus y1 is just y squared square root, right? So d1 is this side, and that's just 0 squared plus y1 minus y squared square root. That's equal to square root of y1 minus y squared, and that's just y1 minus y absolute value, right? Because we're going to square it and square root it. So that's the same thing as y1 minus y or y minus y1, depending on which one's positive. So the point is, the distance here is y minus y1, and the distance here is x minus x1. And we can use the distance formula using points, or we can just see using the y values. The x is the same, so we're just subtracting the y values. And here, the x values we're subtracting because the y values are the same. Okay, so that's part G. G, again, let me just write the answer neatly and box it. So F, this was our answer. G, we have y minus y1 as one of the sides, and x minus x1 as the other side. Okay, so let's go on to H. Find the slope of the line using the results from part G. Okay, let me just read the rest in case that's something helpful. Letting the result in part H equal the known slope m and clearing fractions, we get the equation of a line that goes to the particular point x1, y1 with a slope equal to m. Point slope form of the line is this or this, just like in the math notes. Okay, so if we're going to, so let's go back and just look at part H. It says find the slope using the results from part G. So slope. We know slope is equal to the rise over the run, or the change in y over the change in x. Well, over here in part G, what is the change in y? Well, it's just this distance, and we know the change in y is y minus y1, right? The change in x is just this distance, and we calculate that to be x minus x1. Okay, so that is the slope for part H, and we're done. And then, if what it's telling us is if we let the result in part H, which we just found, equal the known slope m. Okay, so what's the known slope? What is the known slope? I believe we calculated it to be 1/2, right? Yes. So if we have a slope, let's say it's 1/2, and we say it's equal to y minus y1 over x minus x1. So let our slope be known to be 1/2, just for this example, then this is true. Then we can solve for y. We multiply, let me get another color. We multiply x minus x1 to both sides. These cancel out, right? And then we're left with x minus x1 times our slope of 1/2 is equal to y minus y1. And all that's saying is this is our formula for in point slope. Y minus y1 is equal to x minus x1 times our known slope. Okay, so that's what it's saying. They're just basically telling you that you derived the point slope formula yourself through this problem. Okay, so we're happy with this, and we can review it if we're not. And now we understand how to find the point slope equation of a line. This ends CPM Precalculus Chapter 1, number 57.